I'd like to take you on a short journey through a legacy VisualWorks system. And I'd like to show you how a small number of pretty easy metrics can make a huge difference. So this is the agenda for today. First, I'd like to share some information about the setup and the system and the team and so on. Then we reflect on the problem and the solution and some assumptions we had to make to get better insights for that system. Then I'll show you some core queries that we needed to do to gather data from that system. And after that, based on the core metrics that we extracted from the system, I prepared 3 pretty simple visualizations with some metrics to get kind of good insights over that system. And after that, we move on to the conclusion and a little outlook. Okay, first I'd like to shortly introduce myself. I'm a software engineer who fell in love with Smalltalk back in the late 90s when Smalltalk was still a thing. And of course, Smalltalk is still a thing, but I guess you know what I mean. And then after Java took over, I had to do a lot of Java enterprise stuff, and I even migrated myself to the cloud for a couple of years and worked as a cloud engineer. And eventually I was able to return back to the Smalltalk world when I joined Adesso Insurance Solutions around 2 years ago, and now I'm able to do Smalltalk for a living, and that's just awesome. Yeah, thank you. The system we are talking about is an application called Colfear. It has been around for, I think, decades, more than 20 years. It's a complex system, I'd say, for managing company pension schemes, betriebliche Altersvorsorge, as we call it in Germany. We do have a Windows desktop application, and we do have a kind of headless server version. And I'll show you some screenshots in a minute so you get an idea what we're talking about. We're currently using VisualWorks 9.2, but we're almost done with the migration to VisualWorks 9.4. It took a while. The team. The team I'm working in is a core development team. We are 5 Smalltalk developers, but there are a lot of other Smalltalkers with other teams. We do have professional services. We have project-related teams and domain-specific teams. So there is a lot of Smalltalk programming going on, which is pretty cool because there are a lot of cool people to talk with, to learn from, and it's really great. Here are 2 screenshots from the system. On the left-hand side, we see the desktop application, Windows-based, and on the right-hand side, this is the web-based version. It's basically the same that you're seeing, the same domain, and the web version is running in an application server. It's Java-based, and it's calling the Smalltalk backend via RESTful web services. And I think both of those UIs are looking pretty good, aren't they? Yeah. Okay, as you might imagine, this is a legacy system. It's business critical because it is in production for many years. It was born a long time ago. It's huge. We do have almost 7,000 classes, 1 million lines of code. Huge parts of the system are undocumented. It's complex, difficult to maintain, so we do definitely need something to get a handle on the system, to gain an overview over the system, because there is literally no one left from the original team that created the application, and there's no one who has the complete overview on the system. So we need something. Every change in the system might be a risk, because you never know if you turn a screw at the top left, if something at the bottom right breaks. So we need to do extensively testing, and we do have automation and a lot of manual testing. And this obviously slows down the development speed, but we need to do this, and therefore we're always looking for ways to get a better overview over the system, to reduce risk and to identify risky areas of the application. Unfortunately, we don't have the tools available that the Java guys do have, like Sonar Cube to scan the system, or other tools that they do have. And unfortunately, we couldn't manage to get Glamorous Toolkit to work under VisualWorks 9.2. And even Moose is not working, so Moose has been working, as far as I know, in VisualWorks years ago, but it doesn't work right now. So we had to find other ways to query the system. And and then I thought to myself, we are small talkers, we don't have to wait for tools, we can build our own. And this is not too complicated. The whole system is a live object thing. We can query objects, we can do queries against the system, we can find a lot of stuff out about the system. So we started to gather data from the system and do our own analysis. And the decision that we made was that we try to gather data from the system, but we do the visuals outside of VisualWorks because it is easier for us to visualize stuff outside. Okay, therefore we had to do some assumptions, and the main assumption was that it might be sufficient to have a very small set of very lightweight and basic metrics. And this might be enough to uncover problems, highlight hotspots, architectural areas that are risky, and so on. So this is the first assumption. So it may be even simple coupling and cohesion metrics might reveal critical architecture hotspots even before we do deep source code reviews. We also wanted to look at package level stuff to find out if there are packages that tend to be more unstable, have a high instability index. We come to this later. And to identify parts of the system that tend to require more maintenance than others. The third assumption we had was, or maybe it was more like a requirement, that we wanted to have one linear scan to the system, not too heavy weight tooling, running information on runtime tracing and so on. So just one linear scan to the whole system should be enough. So, and of course, the power of visuals. We wanted visuals like scatter plots, bubble charts, heat maps, and so on, to turn those numbers that we do have into stories that we can discuss with developers and stakeholders and managers and so on. Okay, based on these assumptions, we created some really basic core queries and assumed that this should be enough. So this is basically everything that we're doing to query the system. It's pretty simple. We need to iterate over all classes, which is a simple task to do. It's very easy in VisualWorks, and I guess it's pretty easy in other Smalltalk languages as well. We had to iterate over methods. It's also pretty easy, no big deal. A little bit tricky is to get information about references. So is the method I'm currently examining referencing some other classes? But we were able to access the compiled methods of a class and then get a list of literals from that class. And if a literal is of type class, then we know, okay, well, this must be a reference to another class. So no big deal. The main challenge was that these literals could also be blocks, compiled blocks or something like that. So we would need to recursively call this to identify the whole number of references to other classes in the method. So no big deal at all. And of course, finally, we needed to calculate the number of lines of code and number of methods in the class and so on. So everything is pretty basic stuff. So based on these queries, we created a list of core metrics that we wanted to gather from the system. So for each class, we wanted to know the number of lines of code of that class. We wanted to know how many methods does this class have. We wanted to know the number of incoming classes, so how many other classes are calling the class we're currently investigating. We wanted to know the number of incoming packages, so how many other packages than the package I'm currently in are referencing the class we are currently investigating. We wanted to know the number of outgoing packages. To get an idea of the cohesion level of a class we wanted to, or of a package, we wanted to know the internal and external references. So an internal reference would be a class that calls another class that is in the same package, and an external reference would be a class that is in a different package, so basic stuff. And the last thing that I wanted to know is if a class is a surface class. Surface class is a concept I found in a paper by a guy called Stéphane Ducasse. Maybe you've heard of him. Mainly, it tells me if this class I'm currently looking at is exposed to classes that are in another package, so surface class. And this is a screenshot of the main calculation. So that's basically everything. A little bit glue code around and writing everything to a file and so on, but that's all. So by after extracting those data from the system, we wanted to write everything into a flat file, a CSV file, one line per class, with all those metrics I just mentioned, and then import everything into Power BI, so which is a pretty easy task. The idea was to then use Power BI to do additional calculations, aggregations, and of course, visualizations, and maybe some interactive exploration of the data that we do have, and move this everything out of VisualWorks and do this in Power BI. And you might ask, why Power BI? Because Power BI is available, it is cheap, it is very easy to use. You can basically do everything with drag and drop, so pull data in, create visuals, and connect the data with the visuals, so this is pretty easy. But of course, you could use other BI tools like MicroStrategy or Tableau or whatever, so no big deal. But I used Power BI. Okay, and in Power BI, as I mentioned, we created then scatter plots and bubble charts and heat maps and so on to visualize the stuff. Okay, and now I prepared 3 visualizations based on these core metrics. And I'd say we go through those visualizations, and maybe if there's time left, I can show you how to do this stuff with Power BI to show you the interactive style of Power BI, how it can be used to analyze the system. Okay, the first thing I wanted to look at was something that's called instability. And instability is basically the relation between the number of outgoing references. It's a package level number. So we look at the number of references that are outgoing from the package we're currently looking in, and we compare this to the number of incoming references from classes that are in different package. So, and if there is a package that has a lot more outgoing references, we can consider this as a little bit more unstable, because anytime referenced package changes, we might need to change the package that we're currently looking at. So this might be considered unstable, while if only other packages are using my package, that might be considered as stable. So, and of course, I know this is not a good or bad thing. There might be packages that might be unstable by definition. It might be a design decision. So we're not saying this is good, this is bad, but it might help us to identify critical areas of the system. In this visualization, I wanted to add another dimension, and I added the surface class number. So I wanted to know how big is the number of surface classes in a package. So to identify if this package that I'm looking at is highly exposed to other packages or if it's not very much exposed. So I created the number of surface classes on the y-axis here, and the instability is on the x-axis. And so if a package would be on the top right corner, that would mean that this package would be highly unstable, and it would have a high exposure to other packages. So this would be definitely something to look into, while a package that is on the bottom left would be mainly used by other packages, and it would have a very minor exposure. The size of those bubbles we see here, each bubble is a package. The size represents the size of the package.
Do you also take a look at how often they actually change?
No, but it's a good point I took for an Outlook to add those kind of information. So is it heavily changed, or who is changing this? So yeah, but we're not doing this yet. Yeah. So for example, this guy here has a high instability number, and the number of surface classes is above average. And this bubble is pretty huge. So this might be definitely something we should look into. So it might have a high importance regarding the system, and we should look into this. Okay, instability. The next thing I was looking at is a heat map, also package level thing. It's about cohesion. And cohesion, as you probably know, is a measurement to show how closely classes within a package relate to each other. So that's basically everything. So a high cohesion package tends to be more focused. So focused on a technical or on a business domain, while packages with low cohesion tend to be more cluttered all over the place. So, and as this, it's the same with the instability, it's not a good or bad thing. There might be packages with low cohesion that are low cohesion by design, so that might be fine, but we'll try to find out if there's something to look at to prioritize things. So I created a list with a cohesion score. This is the cohesion score. And I found out that there are packages that have a very low cohesion, like, for example, this one here. But this package might not be that relevant to the overall system because it only does have very small code base. So I created what's called an impact score to relate the cohesion score with the lines of code, so the size of the package. And I found out that there are a couple of packages, like the top two here, that do have a low cohesion score, but not the lowest one. But they are probably very critical for the overall system because they do have a lot of lines of code. So these might be two packages to investigate further. Okay, the third and last visualization is also about cohesion on a class level. And I wanted to show you this because of the interactive features of Power BI. Let's see if I find time, if I still have time to look into Power BI. First, I'd like to show this, explain this tree map. It's a tree map, and each of those rectangles represents a class. The size of a rectangle represents the size of the class, lines of code. This is a big class or a small one. And the color of a rectangle represents the cohesion score. So by looking at this, we can clearly see there is this huge class that is not red yet, So it has a cohesion score that isn't good, but it's not that bad. But it might be a problem because it's this very huge class. The interactive features, maybe I can show you this right now. So this is the same thing that we saw on the slide, and that it's very easy to add filters and slicers to Power BI. So I can filter the classes I'm looking at by their package. So if I clear the filters, this would be a list of almost all classes. The smallest one don't get displayed by this tree map. But these is an overview on the whole system. And I can use this slider to just show classes that do have a certain size if I'm interested in. So I can slide into this. And I can filter the classes I'm looking at by their package. So my favorite package of the whole system is the so-called Versorgungsausgleich. And I really love the Versorgungsausgleich. Wait a minute. Lower. There's the Versorgungsausgleich. And I can filter by number of lines of code. And we again see the thing that we have seen on the screenshot. And by doing a mouse over, we can get additional information on the classes we're interested in. We see the method count, the cohesion score, the number of lines of code, the name of the thing. And so it's pretty interesting to drill through and explore the system with this kind of visualization. Okay. Back to the presentation, and basically that is everything we did. I have some conclusions. So even simple static metrics might provide powerful insights into the system and the structure and design concepts and the architecture and so on. Visualizations like heat maps and tree maps and so on might help to uncover hidden complexity and refactoring hotspots. The analysis revealed clearly risk areas, low cohesion classes and low cohesion packages, and also large critical components. And I think the main conclusion we had was that we now do have a whole new level of transparency. So before that, there was a lot of complaining going on. Oh, it's a huge system and we need to refactor things, and we had to explain this to managers why we need budget and time for refactorings. Now we can show them here, this is your system. These areas are red, or these bubbles are large and on the right side. So if we want to improve quality and maintenance and stability and so on, we should move some of those bubbles from right to left. We would need to make some bubbles smaller or change the color of some rectangles. And of course, we can use this to track the progress. So when we agree on some refactorings, we can show them, okay, before it's this, and after the refactoring, we have this. So this is really great, and this is something that even managers do understand. Okay, a little outlook. We would like to automate the metric extraction and the CSV export during the CI/CD pipeline. This is a pretty easy task. We could build a living system dashboard with Power BI. Power BI does have a web-based version that can be used to schedule data updates, so a dashboard that is available for everyone, even managers or the QA guys can look into this, so you would not need to have Power BI installed, or you don't need the IDE or something. So that would be cool. We could integrate other metrics, for example, code churn, test coverage, bug density, maybe dependency graphs, maybe even runtime data. or maybe even team-oriented metrics like contribution diversity. That would be pretty interesting to find out if there is from an architectural perspective, if there is a critical package, and we would find out that only if a limited number of developers is working on this, or is this a critical package and a huge number of developers is working on this. Might be interesting. And of course, we could use these insights for architectural discussions, for roadmap planning, for onboarding of new developers, or as an addition to code reviews. So, okay, and that's all. So thank you very much. And if you have questions, let's go ahead. Thank you.
Hi, Stefan. I found the visualizations that Power BI and things like Tableau are capable of making not very satisfying if I want to see multiple dimensions at the same time. So things like polymetric nested views are much easier to use in things like OSL or GToolkit. You decided to export the data to CSV, then you could also have just imported in GToolkit or Faro with OSL and then made the visualizations there. What was your thinking going there?
Yeah, it was a pure pragmatic decision because it was just much easier for me to import it into Power BI because I have not much experience with Moose or Rosal or so on. It might be easy for you, but in my case, I exported everything, imported Power BI, and I have the visuals. So it was, in that moment, the pragmatic decision. Yeah.
Hey, Stefan. Question. You mentioned in the Outlook some of the things you can do, like using it in plannings, etc. Is it because this is fairly new that it is not happening yet, or is the company not sort of allowing this kind of tools to be used, or what's the reason for not already doing these kinds of things? Because it feels as very valuable to do. Yeah. And as I mentioned to you, I'm in a sort of similar situation, so I'm eager to learn.
Yeah, it's new, that's the thing. I've been talking to managers and they are very interested in this, and they saw those diagrams and they understood what's going on by looking at these diagrams, because it's a very high abstraction level. So, but it was easy for me to explain risks and areas to look in. So they are, from my feeling, are very interested in this, and I'm pretty sure that we will use this in future, but we just started with this. Yeah, thank you.
But to be honest, this is not the whole truth. In 2011, we did the same thing with the method gatherer, and we measured a lot of things about call fear, and it has no impact on management.
Yeah. Maybe it's different, maybe it's a different management. I talked to my manager, he was interested, and of course I know the method gatherer, but in this case it was much easier for me to implement those simple queries and import this into Power BI. So I know that you've created similar kind of data, and maybe the circumstances are different now, but it's what I experienced in the past days. Yeah.
And you can probably use it for your own good as well.
Sure.
If it's not for management, you can use it for your own decision making.
Definitely. When talking about architectural requirements or challenges, so I can use this, of course. Yeah. Okay.
You mentioned runtime information, so I don't know if that is logs as well as some do some frameworks exist or are included in an application that you effectively could track and exploit.
You mean runtime, the runtime thing I mentioned?
There is I would say in Java there is a what is it, log4j or whatever. So does this platform have similar metrics that are logged? So I'm not a connoisseur of other than Faro, but do you have a G2E application, so that has logs by definition, I guess, but your Smalltalk backend has two, I guess. So you log errors of the application or exceptions, etc.
The idea, the runtime information I would like to correlate with the data I just showed. The idea was, for example, to correlate performance measurements. So, or data regarding how long is execution inside a method or something to correlate this. So pure runtime information on performance, for example, to find out if there are packages that are low performance, or maybe there are packages that do have a higher performance. These kind of data. So, yeah.
Thank you very much.
Okay. Thank you.